Today we have this problem. It's called last stone weight. You are given an array of integer stones where stones of I is the weight of ith stone. We are playing a game with the stones. On each turn, we choose the heaviest two stones and smash them together. Suppose the heaviest two stones have weights x and y, with x less than y, less than or equal y. The results of this smash is x equals to y. Both stones are destroyed. X doesn't equals y. The stone of weight x is destroyed, and the stone of weight y has a new weight y minus x. Okay. The end of the game. The end of the game. There is at most one stone left. Return the weight of the left remaining stone. If there are no stones left, return 0. Okay, so we have this stones array, and output should be 1, because first of all we take the biggest two, 7 and 8, and the remaining will be 1. And we will have just 3, 5, and I guess 2, 4, 1, and 3 ones. Yeah. And after that we have 2 and 4, and the remaining will be 2, so it will be 2, 1, 1, and we have 2 and 1, the remaining will be 1, and it will be have 3 ones, and just after that we just have 1 and 1, and both of them destroyed each other, and we have 1 lost. And let's just, because I want to, let's just think about this problem, because there is tons of different approaches to this problem. Let me just, okay, so if you remember with the array, let's say that we have the array. Okay, let's say that we have an array that have like 1 and 2 and 4 and 6 and maybe 7, 9, and that's it. And we wanna we'll take the biggest two things. Like if we take these biggest two things, we will have 2. Okay, so the array will be 1 and 2 and 4 and 6 and 2. And we take the biggest two of them, like that, will be only 2. So it will be 1, 2, 2, and 2. If we take these two things, both of them are destroyed, so we have 1 and 2. So if we take 1 and 2, it will be, we left with 1. So how can we solve this problem? There's tons of different ways. We can just first do a brute force. Yeah, I guess the time complexity will be of 1 squared. We can do a heap, or and this will be the I don't know, but it could be n log n or something like that, because he will be give out that things, because we will use a priority queue. Or there is multiple different approaches, but in my mind coming one specific approach, which is to use a recursion. First of all, we didn't used a recursion for a very long time in our channel, so this is one. Second, it's efficient. So let's see how we can do this recursion. So we create the function, okay, and first of all we will sort the array. Our array is sorted, so we don't have to care about that, but just make sure that we should sort the array. First of all, we say that if when we have a recursion function, we build the base case. So the base case will be if the length is equal than or less than 1, or maybe if the stones and if the stones length equals 1, we return 1. If there is no length, maybe like all the stones destroyed each other, we return 0. However, let's start in how we can solve the code. So first of all, we store it. This array is already stored. So after storing, we will just take x and take y. Let's just see, this is x and this is y. Okay, and y, the new y will equals, we will have like just equals, let's say that it will be the new y. We will add y, add y again. Okay, and stone dot push, we will push this y, this new y, to the array. Okay, and after that we will keep calling this function on this array until the length of the array becomes 1 or less than 1 or 0. So this is the what we are going to do. Okay, so let's start into it. So first of all, we have a recursion function. What we should do in the first thing, we should choose what is our base scenario. Our base case, it will be if wait a minute, I will say if stones dot length less than or equals 1. I will say if it's less than or equals 1, there's two possibilities. The length is equal 1, and if the length is equals 1, if stones dot length equals 1, I will return stones of 0. Okay, however, if it doesn't equals 1, that means there is no remaining elements. Maybe like everything was destroyed, everything was full of the equal stones. So I will return 0 because there's nothing to return. Okay, we finished the base case. I will say else I will say stones. First of all, we sort A and B, and A minus B. Okay, and I will say X will equals stones dot pop, so it's the biggest one, and Y it is the next biggest one. So I will say let X and let Y, and I'll say Y. First of all, I want to make sure that if I and X equals to each other, I just pop them and I just remove them from the array. They are already removed in the array. The thing that I want to do is that I want to push this. First of all, let's just take the remaining of them. I will say Y will equals Y minus X. Okay, and I will say that if let's just say that if X doesn't equal Y, so we do this calculation, otherwise we don't have to do it, because if they equals each other, that means both of them are deleted. So that's it. And I will push stones dot push. I will say stones first. However, I just push the array stones dot stones dot push. What stones dot push? I guess minus Y, because if Y is the smaller and it's minus Y, it will like minus equals positive. So we return this array again, this function again, and we pass the new stone array that we implemented, that we remove the last two elements, and after that we take the remaining, and we push the remaining to the array, and we call the function again. Else, if they are not, if they are not equals each other, that means they are equals each other. If they are equals each other, else if they are equals to each other, I will just call the array. I will just call the function again. I don't have to push anything to the array, and I guess that's it. Okay, there is something weird. Look, this is like was a few seconds ago, like 15 minutes. When it was beating 90%. Right now it's beating only 40. However, let's just discuss the I'm gonna take this one because this one looks better. It's the same solution, but it just looks better. Yeah, because I don't have to manage everything. Okay, so let's just describe what we have. Let's just add this one because the recursion's problem needs a lot of description. So let's say that we have the stones and we have this array. Okay, and I'm saying that stones.length, first of all, this would be a recursion function, and all the time that when we start recursion, we just build our base case, and our base case here, it should be if the length is 1 or less than 1. That means there is nothing more to compare. So when there is nothing more to compare, we return the remaining. Otherwise, if there is no remaining, we return 0. Okay, after that we start to this one. We sort the array. First of all, we sort the array. So let's just sort the array. So it will be 1. It will be 1, 2, no, 1, 1, 1, 2, 4, and 7 and 8. Okay, and after sorting the array, we will say that we are popping x and y. So let's just have x and y. First of all, we pop them. X will equal 8 and y will equal 7, and we pop them, so we're deleting them from the array. And y will equal the minus x and y, so it will be 1. But however, I'm saying that if y doesn't equals x, x doesn't equals, and this is what we have, so y will equals 1, and we push 1 here. Okay, and we call the function again. We call this function again, and we just go from the up. Is the stones.length less than or equals 1? No, this is not right. So this if statement is not working, so we just sort again. So when we sort, we put this one into the end. So okay, and after that we will have x and y, and it will be 2, and y will be 4, and then your y will be 2, because 2 minus 4 will be 2. And we will push, and we just delete this 2, 4, and we push the remaining, which is 2. Okay, and we call this function again. Okay, and we just to go back, is the stone.length less than or equals 1? No, they are still 4. Okay, so ignore this, sort the array. So we're sorting again. However, the array is sorted, no problem. So I'm taking x dot stones pop, I'm taking y and x, so y and x, it's 1 and 1, and the remaining will be 1. And I push this one, I will delete these two things last, and the remaining will be 1. Okay, and I'm calling the function again, and I will go with the function again. I will say if stones.length less than or equals 1, no, they are 3. So we sort, the array is already sorted, and I'm saying that if x doesn't equals y, but this is, will not do that because x equals y, so we just pop them, and we doesn't do anything. Okay, we have remaining y, and we call the function again. And in this function, we say that in the last function, we say that stones.length equals 1, or yeah, it's equals 1. So if stones.length equals stones.length less than or equals 1, yes. Okay, if stones.length equals 1, return the first one, so we return 1, and that's it. So that's it for this video. I hope my solution was quite good. If you like my solution, make sure to subscribe, hit the notification bell so you will never miss a video, and see you in future problems.